So good morning, students. Welcome to Fluid Mechanics 2 video session. So in the previous class, we discussed about, different heads in the pumps and centrifugal pump. And also we discussed about the losses in the centrifugal pump. And also we discussed about the efficiency of the centrifugal pump, right? So in this particular class, we are going to we'll solve some numericals, okay, based on the centrifugal pump. Okay. So without wasting the time, let's start. Let's take the first problem. See, the impeller of a centrifugal pump has an external diameter of 450 and internal diameter of 200 and it runs at the 1440 rpm, full stop, assuming a constant radial flow through the impeller at 25 meter per second, and that the vanes at exit are set back at an angle 25 degree. Determine inlet vane angle. The second one is the angle absolute velocity of water at exit makes with the tangent. And also the third one is the work done per Newton of water. So this is the first question. And obviously, for every problem, first what you have to do is read the question once again properly and write down all the given information so that you'll understand that what information they are given and what, by using those information, how we can find out the whatever the is asked. Okay. So let's read once again and write down the given points. See, the impeller of the centrifugal pump has an external diameter of 450 and internal diameter of 200 So that means he has given the internal diameter of the impeller and also the external diameter of the impeller, that is capital D1 and D2, where D1 indicates the internal diameter and D2 indicates the external diameter. So internal diameter is D1 is 200 and external diameter is 450 Okay. So next one is, and it runs at 1440 rpm, that is capital NDI, that is speed of the impeller. So speed of the impeller is equal to capital N is equal to 1440 rotations per revolutions per minute, that is rpm di. The next is asking, he is telling that assuming a constant radial flow through the impeller at 25 meter per second, that means a constant radial flow of 2.5 meter per second. So that is VF1 and VF2 is given. So velocity of the flow is VF1 or VF2 is equal to 2.5 meter per second उसने दिया है. And that vanes at exit are set back at an angle 25 degrees. So that means he has given the phi angle. And this is theta is at what you can say at inlet and phi is at the outlet, right? So vane angle at outlet is given, that is phi is to 25 degree the other. So by using these informations, you need to calculate or you need to determine the inlet vane angle. So inlet vane angle means that is theta. So you need to find the theta. Okay? And the second one is the angle, that is absolute velocity of water at exit makes with the tangent. That is, I think he is asking to find the beta, and also is asking to find the work done per Newton of water. Okay? So let's start with the inlet vane angle. So to solve this particular problem, you should know this velocity triangle diagram for the centrifugal pump. Okay? So this is the vane, correct? This is 1 indicates the inlet point and 2 indicates the outlet point. So if you draw the diagram, so this is a same diagram, it remains same. Only thing is you should know in this particular diagram where is VR1, VF1, VW1, U1, U2, theta, beta, phi, all these things you should know. Then only you can solve the numerical. Okay? So you can say this is VR1, that is relative velocity at inlet point, which is making angle with this U1, that is theta. So this is inlet vane angle. Okay? So this is V1, which is also equal to VF1, and alpha is equal to 90 degree and VW1 is equal to 0. These things we already discussed in the previous classes. Okay? And where VF1 is equal to VF2. That's why he told he has given V1, which is equal to VF1 and VF1 is equal to VF2. So that's why I written V1 is equal to VF1 is equal to VF2 is equal to 2.5. लिखा था, ठीक है। So now what he is asking is asking to find the theta. That is theta is the angle made by the inlet vane angle. Correct? है? So obviously you know this is very simple trigonometric use करके you can find out the theta. So that is tan theta is equal to opposite by adjacent लगा सकते हो. So tan theta is equal to opposite by adjacent. Opposite क्या है? It is V1 है. So you can V1 or VF1 you can take it. Actually this is VF1 है. Correct है ना? And divided by adjacent. Adjacent is क्या है? U1. So that is VF1 divided by U1. So you can write tan theta is equal to VF1 divided by U1. So now VF1 is already given, that is 2.5 meter per second, but we don't know U1, but U1 can be calculated easily by using that formula. So which you know U1 is equal to pi d1 divided, pi d1 n divided by 60. If you want to calculate U2, that is pi d2 n divided by 60. Simple formula. So we need to find out U1. So U1 is equal to pi into D1 into N divided by 60, where pi D1 is is given, that is internal diameter of the impeller, that is 200 mm. So 0.2 meter. So you can write pi into 0.2. N, it is already given, that is speed of the impeller, that is 1440 RPM. So 1440 लिख दिया है, divided by 60, you will get 15 UN na? U1, that is what we can say, velocity at inlet point, absolute velocity, right? So that is 15.08 meter per second. Teacher, 15.08 meter per second is the U1 value. So now you substitute this one in this particular first formula U1, and you already know VF1. So that is tan theta is equal to 2.5 divided by 15.08, or theta is equal to tan inverse of 2.5 divided by 1508. You will get that is tan inverse of 0.1658 किया तो theta is equal to 9.4 degree IR. So that means first you got to know inlet vane angle is equal to 9.4 degree. ठीक है. So let's go for the second question, sub question, that is the angle, that is absolute velocity of water at exit makes with a tangent. So that means absolute velocity making an angle with tangent. So this is absolute velocity, okay, which makes an angle with the tangent, that is this one, which is nothing but beta. So we need to find the beta. Okay, one second, where is this? Okay, so you need to find out the beta. So once again you can go with the beta angle find out करने के लिए once again trigonometry पे जा सकते हो. That is tan beta is equal to opposite by adjacent. So we know VF2, we know VW2 you can be calculated. ठीक है. So like that you can calculate the beta. Same by using the geometric trigonometric equations use करके आप find out कर सकते हो. So let's start with the second question, that is second sub question. See the angle absolute velocity of water at exit makes with the tangent, that is tan beta is equal to VF2 divided by VW2. So you can see here, one second, I will take this one. So tan beta is equal to opposite by adjacent. So that is VF2 divided by VW2. Okay. So VF2 we already know, but VW2 we don't know, right? Sorry. See, to find the VW2, right? So we should know what is U2, and U2 can be calculated. How you can calculate U2? Once again, the formula, this U2 is equal to pi d2 n divided by 60. So that is what we are doing. U2 is equal to pi into d2 into n divided by 60, where d2 is given, that is 0.45. You can see here, d2 is 0.45 meter. You substitute that one, 0.45, and n is, you know, 1440 divided by 60. So you will get U2 is equal to 33.93 meter per second. Okay. So now you got to know U2. So why I found out U2 means to find the VW2, because the formula is, you can see here, VW2 is equal to U2 minus VF2 divided by tan phi, or you do tan phi. Okay. So tan phi अगर लगाया ना, see if you apply tan phi here, that is opposite by adjacent. Opposite क्या है? VF2 divided by this one adjacent. Adjacent क्या है? U2 minus VW2. So if you VW2 के लिए इक्वेशन लिखा ना, So you will get this equation. VW2 is equal to U2 minus VF2 divided by tan phi. So U2 हमारे पास है 33.93, VF2 हमने कैलकुलेट करके रखा है 2.5 एंड फाई एंगल हमको पता है tan 25, फाई एंगल 25, ठीक है। सी VW2 बीटा कैलकुलेट करने के लिए आई नीड VW2, सो VW2 कैलकुलेट करने के लिए आई कंसिडर दिस ट्रायंगल वेयर आई नो VF2 फाई सब पता था इसलिए, और U2 भी कैलकुलेट कर सकता था। सो 2.5 divided by tan phi is 25 degree. So VW2 आया 28.57 meter per second. So now you got to know VW2 and also you have VF2. VW2 कैलकुलेट किया, VF2 हमारे पास है, आराम से tan बीटा कैलकुलेट कर सकते हैं। tan बीटा is equal to VF2 divided by VW2 is equal to 2.5 divided by 28.57. That comes 0.0875. Tan inverse of 0.0875 is nothing but that is beta is equal to 5 degree. So you got the second answer. Theta calculate किया था, it comes around 9.4 degree. Second sub question था beta calculate करो, that is 5 degree आया. The last question is you find the work done per Newton of water. So work done per second per unit weight is equal to, formula हमको पता है 1 by G into VW2 into U2. So you know G, you know VW2, you know U2, just substitute all those things. 1 divided by 9.81 into 28.57, that is VW2 इधर कैलकुलेट किया है, एंड ऑल्सो U2 कैलकुलेट किया था ऊपर ही 33.93, you will get 98.81 Newton meter. That is work done per second. ठीक है, so that is the first question. I hope आपको समझ में आया. Simple question है. Only thing is you need to remember this velocity triangle diagram. Let's move on to the second problem. The impeller of a centrifugal pump having external and internal dia 500 mm and 250 mm respectively, width at outlet 50 mm and running at 1200 rpm, work against a head of 48 meter. The velocity of the flow through the impeller is constant and equal to 30 meter per second. The vanes are set back at an angle of 40 degree at the outlet. Determine the inlet vane angle. Second one is work done by the impeller on water per second and manometric efficiency. Okay. Okay, let's once again read the question and understand the question. Write down the given. First, the impeller of a centrifugal pump having external and internal diameter, that is D1 and D2. So it is given D2 is 500 mm, that is 500 mm is external and internal is 250 mm. So D1 and D2 लिखा, obviously converted to meter, 0.5 meter and 0.25 meter. Width at outlet 50 mm, that is width of the outlet, that is B2 given is equal to 50 mm, that is 0.05 meter. ठीक है, and running at 1200 rotation per rpm, work against a head of 48 meter. So capital N दिया है 1200 rpm है, and he has given the head of 48, work against the head of 48 meter. So he has given head, that is monometric head. Monometric head आपको already last class में बताया था. Monometric head is nothing but the head, that is the work against the all this whatever the head is there, correct है? So that is called as the centrifugal pump has to work against that head, that is monometric head is equal to 48 meter. So वो भी पता चला. Then the velocity of the flow through the impeller is constant and equal to 30 meter per second. So he has given the velocity of the flow, that is Vf1, which is equal to V1 or which is equal to Vf2. That is Vf1 is equal to Vf2, 30 meter per second. And finally, the vanes are set back at an angle of 40 degree at the outlet. So he has given once again phi, that is 40 degree. Okay. So what is asking? Inlet vane angle, that is theta is asking. Okay. Second one is work done. So you know monometric efficiency. So once again, write the diagram. Okay, you should know where is theta, what is Vf1, Vf2, beta, phi, everything. Once again, finding theta is very easy. Apply tan theta is equal to opposite by adjacent. Opposite is VF1 divided by U1. So UN कैलकुलेट कर सकते हैं, VF1 ऑलरेडी दिया है. UN कैसे कैलकुलेट कर सकते हैं? पाई D1 डिवाइडेड बाय 60. सॉरी, पाई D1 n divided by 60. So tan theta is equal to VF1 divided by U1. UN कैलकुलेट करूंगा फर्स्ट, पाई इंटू D1 इंटू n इंटू डिवाइडेड बाई 60, वेयर पाई पता है, D1 दिया था 0.25 इंटू एन कैपिटल एन दिया है 1200 आरपीएम डिवाइडेड बाई 60, तो आपको मिलेगा UN इज इक्वल टू 15.7 मीटर पर सेकेंड. नाउ यू सब्सटीट्यूट UN एंड VF1 तो ऑलरेडी दिया था, किधर है VF1, दैट इज 3, सो दैट इज 3 डिवाइडेड बाई 15.7, दैट इज 0.191. सो थीटा इज इक्वल टू tan इनवर्स ऑफ 0.191 किया तो आपको मिलेगा 10.8 डिग्री. So that is your vane angle, inlet vane angle, that is theta. ठीक है. Let's go for work done, that is second problem. Work done by the impeller on water per second, आपको पता है work done per second is equal to rho into Q into VW2 into U2. U2 कैलकुलेट कर सकते हैं, बट हमको Q पता नहीं है and VW2 पता नहीं है, right? So once again VW2 it can be calculated. Last problem में हमने आउटलेट पॉइंट पे ट्रिग्नोमेट्री यूज करके VW2 कैलकुलेट किया था, बट न्यू थिंग इज Q फाइंड आउट करना है. ठीक है. सो Q इज नथिंग बट डिस्चार्ज, दैट इज एरिया इनटू वेलोसिटी, दैट इज एरिया ऑफ द इंपेलर इनटू वेलोसिटी ऑफ द फ्लो. सॉरी, एरिया ऑफ द इंपेलर इज पाई इनटू D1 इनटू B1 इनटू वेलोसिटी ऑफ द फ्लो इज VF1. सो दैट्स व्हाई B1 is given to find the discharge. So area of the impeller is pi d into B, that is by D1 into B1 into VF1, or pi D2 B2 VF2. But we don't know B2, we know B1, that's why I'm taking this equation. So pi into D1 कितना है, 0.25 है, B1 दिया था 0.05, that is 5 mm दिया था, VF1 3 मीटर पर सेकेंड दिया है. सब्सटीट्यूट करो, कैलकुलेट किया तो आपको मिलेगा डिस्चार्ज इज इक्वल टू 0.2356 मीटर क्यूब पर सेकेंड. सो आपको इधर Q मिल गया, रो पता है. नाउ आई नीड टू फाइंड आउट द VW2. सो VW2 फाइंड आउट करने के लिए मेरे को ये ट्रायंगल लेना पड़ेगा. सो tan phi कंसिडर करता हूँ. tan phi इज इक्वल टू VF2 डिवाइडेड बाय U2 माइनस VW2. सो यू कैन सी हियर tan phi is equal to VF2 divided by U2 minus VW2, or VW2 is equal to U2 minus VF2 divided by tan phi. U2 कैलकुलेट कर सकता हूँ, that is by using this formula, pi D2 n divided by 60. D2 वैल्यू दिया है, n वैल्यू दिया है, सब्सटीट्यूट करो, U2 मिल गया 31.41. सो VF2 पता है, phi पता है, U2 पता है, VW2 कैलकुलेट करो. ठीक है. So VW2 is equal to 31.41 minus 3 divided by tan 40. VW2 मिल गया 27.8 मीटर पर सेकेंड. So that means आपको अल्टीमेटली VW2 मिल गया, U2 मिल गया, Q पता चल गया, रो तो पता है, तो वर्क डन पर सेकेंड आराम से कैलकुलेट कर सकते हैं. वर्क डन पर सेकेंड इज इक्वल टू रो इंटू Q इंटू VW2 इंटू U2. रो इज इक्वल टू 1000, Q is equal to 0.2356, VW2 is 27.83 and U2 is 31.4. Substitute करो, work done per second is nothing but 205.95 किलो न्यूटन मीटर. न्यूटन मीटर पे आता है बट किलो न्यूटन में कन्वर्ट किया. ठीक है. 205.95 किलो न्यूटन मीटर. This is the second sub question. The last one is asking manometric efficiency, and you know directly the formula. Manometric efficiency is equal to G into HM divided by VW2 U2. VW2 पता है, U2 पता है, G पता है, HM ऑलरेडी दिया है न्यूमेरिकल में, that is head against which the impeller or motor has to work, or sorry, centrifugal pump has to work, that is 48 meters. Head, manometric head. ठीक है. So manometric efficiency is equal to G into HM divided by VW2 U2. G 9.81, HM 48, VW2 कैलकुलेट किया था 27.8 मीटर पर सेकेंड, U2 कैलकुलेट किया था 31.41. Substitute, so you'll get manometric efficiency is equal to 53.86%. So this is the second problem. ठीक है. अगर आपने देखा ना, सो बहुत सिंपल न्यूमेरिकल्स है, फॉर्मूला थोड़ा याद रखना है, और दिस ट्रायंगल बहुत इंपॉर्टेंट है. ठीक है. होप आपको ये समझ में आया. सो नेक्स्ट क्लास में आई विल कंटिन्यू विद सम मोर पोर्शंस, दैट इज मिनिमम स्टार्टिंग स्पीड ऑफ द सेंट्रीफ्यूगल पंप. एंड उसके बाद मैंने पहले भी बोला हूँ, एक 2-3 क्लास में खत्म हो जाता है. ठीक है. थैंक यू.